Hey, what's up, guys? This is Chung here again. So today, let's take a look at today's daily challenge problem, number 1283. Find the smallest divisor given a threshold. Hmm, cool. So it's a medium problem. Given like an array of integers and an integer threshold, we will choose a positive integer divisor and divide all the array by it and sum the result of a divisor. Find the smallest divisor such that the result mentioned above is less or equal to the threshold. Okay, and each result of the division is rounded to the nearest integer greater or equal to that element. Basically, we're doing like a ceiling here, right? That's why 7 divided by 3, we have 3, not a 2. We're not doing a flooring, we're doing a ceiling. And it is guaranteed that there will be an answer. So here we have some few examples here, right? I mean, for example, we have number 1, 2, 5, 9, and if we choose divisor 1, right? If we choose divisor 1, then of course the sum is 17 because 1 divided by 1 is 1, 2 plus 2 plus 5 plus 9. And if the divisor is 4, the sum is 7. And if the divisor is 5, the sum will be 5, right? And it asks us to find the smallest divisor. Then obviously the answer is 5. Cool. And keep scrolling down here. We have some constraints here. So first, the number of the length of the numbers, right, is like 10 to the power of 4, and the value of the number is like 10 to the power of 6. Okay. So for this problem, of course, the brutal force way will be obviously we try all the divisors, right? And for each of the divisor, we try all divisor from 1 to what? We try all divisor to 1 to 10 to the power of 6, because 10 to the power of 6 is the highest we can go, because the other than that, because when we have the highest number, all the division will equal to 1, right? All the result will be 1. And we for each of the divisor, we try to calculate their sum, right? Obviously, it's going to be a n square, and it will TLE. So by this time, I think most of you may have already found out the solution for this problem is a binary search. Okay, since basically we search the smallest divisor directly, right? And while the divisor is increasing, right? If the divisor is increasing, then the final answer, the final summary, the total sum will always be decreasing, right? So basically, the bigger the divisor is, the total sum, the smaller the total sum is. That's why we can use since they are like so since it's always increasing and the other side is always decreasing, that's why we can use binary search. It satisfies all the binary search condition. Okay, cool. So as long as you can figure out this, we should use a binary search for this problem. I think the rest should be pretty straightforward. It's just uh, the binary search template. Okay, so for the binary search template, uh, I'll just write it real quick here. So we have a left equals to 1 and right equals to what? 10 to the power of 6. Why is 1? Because this is a divisor we're searching for, right? So the divisor cannot be 0, so that's why we start from 1, and the maximum is a 10 to the power of 6, because that's the biggest number. It's the biggest value the number can get, right? And then okay, so then there you have the template here. While the left equals to right, smaller than right, we have a middle. Okay, and then right minus left divided by 2. So we do these things. We don't do a left plus right divided by 2 is because we don't want to avoid the value overflow, right? And then we have a helper function, right? We have helper functions. This means that with the current middle values, can we satisfy the condition, right? If we can, what do? Now it's the time to go back to the problem. Since the problem is asking us to find the smallest. If you guys have seen my other binary search videos, every time when the problem is asking you to find the smallest, it means that we have to set the right to the middle. Same thing, if it asks us to find the maximum or the biggest number, we need to do when the helper is true, we have to set the left equals to middle, because we're setting the right equals to middle as if we're trying to push this right uh, pointer to the left as much as far as possible. That's why we can get the smallest number, right? Same thing for the maximum num for the max number for the max number we do a left equals to middle, and then we try to push this left pointer to the right as far as possible, right? Yeah. Okay, and we have a left equals to middle plus one, right? Since we have a right equals to middle, we don't have to do a plus one here. If we have a left equals to middle for the maximum numbers, we have to do a plus one here. Okay, that's part of the template. Okay, and then we simply return the left. Okay, that's that. So now let's define the helper function. Okay, helper function is middle. So the helper function is simply check, given this middle value as the divisor, can we get a total sum whose value is small is equal or smaller than the threshold. If we can, we return true, otherwise false, right? It is as simple as that. Okay, so we have a total equals to 0, right? And then we just loop through the numbers. And total plus what? We have a since we're the division is like the divide is like a ceiling, so we need to call ceil method to get the ceiling value divi divided by the middle, right? And then every time when we have a total, we simply check if the total is greater than the threshold, right? If it's already greater than the threshold, we can just simply return here. We return false. We don't have to continue our loop here. Even though this early termination will not affect the final time complexity, but it's always nice to have it here, right? So return true. Okay. Yep. I think that's it. All right. Run the code. All right. Cool. So this accepted. Submit. All right. Cool. Yep. I think that's it, right? I mean, oh, so for the time space complexity, I think it's pretty straightforward, right? So I think let's say the number, right? So we have a log in here, right? So that's a log what? Log let's say that the length of the number is n, okay? And the maximum number of the number is m. So first for the binary binary search, we have a log m here. So that's the time complexity for this while loop. And then for each of the binary search, we have a helper function. So we have an n here. So it's a n times log n, right? So that's the time complexity. Space, of course, 0, right? Sorry, the space complexity also is O1 because we're not using any additional space other than this left and right pointer. Cool. Yeah, that's it for this problem. Thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.